Welcome, everybody. Good afternoon, and thank you for joining this safety roundtable in Rail Safety Week. Delighted to partner up with Rail Safety Week to deliver this Slips, Trips and Falls Masterclass, and we're going to be focusing very much on what you can do within the environment of the rail sector to mitigate the risk of slips, trips, and falls. I'm going to be talking to you about some sort of general principles, but then giving you examples from the rail sector where we've done a lot of work. And so I'm going to have some pictures and case studies and so on and so forth. If you're joining live on Zoom, welcome and thanks for being with us. If you've got any questions, fire them into the chat, or there'll be opportunities as well to raise your hand and unmute and come and ask me a question as well. If you're watching this on a live stream or you're catching the recording, feel free to just put a question into the chat and we will monitor it over time and try and make sure we get back to you. If we don't answer you straight away, we'll get back to you and answer your question later on. So let's get started with just a few introductions, just to check everyone's listening. So let us know in the chat where you're watching from. So where are you geographically in the world? Are you in London? Are you in Dubai? Are you in Singapore? Although it'd be quite late at night in Singapore. Are you watching early in the morning from the US or Canada? And are slips a relevant risk to your organization, slips and trips? The data would suggest they are if you're in the rail sector. Indeed, if you're in pretty much any sector. But let us know if they are relevant to you in the chat. Now, this is a safety roundtable. The concept behind this is that we meet every 2 weeks on Zoom, as well as it's streaming in a couple of places. We have a different topic each time. It's either me talking about a topic, or it's me and a guest introducing a topic and then having a discussion. So if you get value from this session, I'm sure you'll get value from upcoming sessions that we're going to be doing on here as well. So do invite your friends, colleagues, and other safety professionals to join us. So why is it that I, as I'm going to explain in a minute, focus in my business predominantly on slips? We do look at trips and falls as well, but why do we focus predominantly on slips? So here on the screen, you can see some HSE data, and this is RIDDOR, reportable injury data for 10 years up to 2022. I should update this slide, I suppose, but basically the number and the trend that you see is exactly the same, which is that slips, trips and falls very consistently year after year is more or less 30 to 33% of RIDDORs. Now, within that category of slips, trips and falls, and I'm going to break this down a little bit later, slips makes up the majority. Looking specifically at slips, so this is with trips on top, we're talking in the UK about a broken bone every 3 minutes, 300,000 A&E admissions, 1.5 million NHS bed days, and lots of other financial, human, societal, reputational costs as well. What about the rail sector? Here's some data from the rail sector in the UK. Causes of mainline non-workforce severe injuries in stations 2022 to 2023. Slips, trips and falls, 574 injuries, which was 67% of severe passenger injuries in stations in that calendar year. So that is 10 per week, 1 per day, just over 1 per day severe injuries from slips, trips and falls in the UK in train stations. What about some London Underground data? Causes of non-severe injuries to non-workforce, so passenger injuries that weren't severe, same year, 2022 to 2023. Slips, trips and falls, again, I haven't put the number on here for some reason, but it's 2/3 more or less of those. But in spite of that data, it is possible to stop slips, trips, and falls. Here's a few examples from different sectors. Even in swimming pools where the floor's wet all the time, we've seen 85% reductions in claims volumes. Even in hotel bathrooms where it's designed to be wet, 85% fewer accidents. And I'm going to speak to you a bit later about a project that I ran in Euston Station about 10 years ago, where we recorded 60% fewer accidents. So even in a busy mainline train station like Euston, it's possible to significantly reduce the number of incidents. So that's a bit of background as to what we're going to talk about, but just a quick intro to me for those of you that don't know who I am. My name is Christian Harris. I'm the founder of Slip Safety Services. I run this safety roundtable every couple of weeks, as I mentioned. I also host the Safety and Risk Success podcast. I'm very prolific and active on LinkedIn, where I've got a Safety and Risk Success newsletter with over 10,000 subscribers and a Safety and Risk Success group with nearly 20,000 members. So talking all day long about things to do with safety and risk management. But my predominant area of specialism is in slip prevention. And in that domain, I've worked in some high profile cases. I'm going to talk to you about this case a little bit later on. We, as a business, have won some awards. We've got some great partners with the likes of AXA Insurance, and we've got some great blue chip clients. We do some work with Network Rail, people like CBRE. We also do a lot of work with organisations such as IOSH, where we deliver talks. We've helped several thousand sites to mitigate their slip risks over the last few years. And at last count, we reckon we're preventing about £10 million of claims a year. So the equivalent of 3 of these lovely houses or mansions or castles, whatever the right word is, that you can see here on the screen. So that's just a bit about me to hopefully give you a bit of confidence that I know what I'm talking about when I start speaking about this topic. So let's get into some detail here. Slips, trips, and falls. We already mentioned that these are bunched together as a single category in the HC data, for example. But it's important to know that slips, trips, and falls are not the same thing. They're very different. If you've got a problem with someone slipping, the way you would deal with a trip issue is not going to help you, and vice versa. Falls on the same level are typically caused by slips or trips, so it's important to understand what the driver of the falls are. But also it's important to know that you can have a trip or indeed a slip and no fall, and you can still have people injured by a slip or a trip where there isn't a fall. Which some people seem to gloss over sometimes. Now, I've got here some insurance claims data, and I mentioned earlier that slips is a much bigger category than trips. Here's some evidence for that. So in the retail sector, and these are insurance claims of under £25,000 in value, slips account for 20% of claims and trips account for 8% of claims. So in the retail sector, more than twice as many slips versus trips. In the hospitality sector, 33% slips, 7% trips. So significantly more slips than trips. And in the manufacturing sector, 38% slips, only 3% trips. So slips is a much bigger problem statistically than trips. But it's also a more complicated thing to solve. And you're going to see by the end of this presentation, hopefully, that you need to take a more scientific approach to slips. So if we're looking at trips, this is the methodology, the philosophy, the framework that I always recommend people use. Trip, tidy, route, identify, plan. So if you've got a problem with trips, and remember, you need to figure out if you've got a slip or a trip problem. If you've got a problem with trips, these are the 4 philosophies that you should focus in. Tidy, which is all about housekeeping. Now, we need to remember that trips are caused by an obstruction at a low level that somebody either doesn't see or isn't able to avoid, and their foot strikes it and then they trip and go forward. So you have permanent obstructions and you have temporary obstructions. And the temporary obstructions are the ones here where if we can focus in on tidying, on thorough housekeeping, we can prevent those incidents from happening by removing the temporary obstructions. R is for route. So this is all about creating defined walkways. If you can funnel people down a particular passageway rather than allowing them to walk here, there, and everywhere, obviously then you can focus your efforts on that defined area rather than having to spread yourself too thinly. So where possible, see if you can route people down a particular path. Identify, this is about raising awareness of hazards. So it's firstly about raising awareness overall, but secondly about people keeping their eyes peeled and actually proactively looking for these hazards. So, if you see a trailing cable, do something about it. Don't just walk past it. And then P is for plan, which is all about good design and maintenance. So a lot of trip hazards which are permanent are introduced through the design phase and or through ineffective maintenance. So if we can get on top of planning, then we can really get on top of trips. Here's a tip that I use quite often, which is that you can use a pound to stop trips. Now you can use a pound, you can use a trolley coin. Those are the same size. And actually, we've been doing some work with the NHS where they've done some NHS branded trolley coins for this exact purpose to help them to identify trip hazards that they need to address. So what you do is you get your pound coin or your trolley coin and you lay it down flat on its surface. And if the lip of the potential trip hazard exceeds the height of the coin, then you should try to address it. And if it's a bit below the size of the height of the coin, then just monitor it. So this is a really easy way of just saying, right, how do we focus in on the trip hazards that are going to make an impact for us and where we should put our efforts in. So here's an example from a railway station that I took recently where you've got tarmac, which you often see on external platforms, and you've got a drain. I should have taken a photo with the pound coin on the floor, but I didn't. But the size of that lip exceeds the height of the pound coin, and therefore the recommendation would be you should try and do something about that to mitigate that trip hazard, because that is likely to cause somebody to trip. And obviously, if you're tripping on a station platform with a hard floor, you're liable to suffer from an injury. So that's kind of it on trips. It is relatively simple. One of the challenges, though, is that because we bundle together slips, trips, and falls, we often speak about simple solutions, or these are simple things to solve. And the problem is that slips are not as simple as that to solve. Slips are much more scientific. Trips are simple. So we need to make sure that we understand that we need to split these two things out and deal with them slightly differently. By the way, any questions that are coming up, just fire them into the chat and I'll try and monitor them and pick up on them either as we go or at a different point towards the end. So we've developed an approach to solving slip hazards or issues, which we call slipology. And the idea there is to marry up slip and science. And there are 5 stages to this process: assess, amend, advocate, assure, and affirm. We haven't got time to delve into the whole model today. I'm going to be focusing in on assess and amend, which is basically understand and then do something about it. So we're going to be focusing on the first 2 steps today, but this does work like a foundation. So if you haven't got the assess bit right, then you're not going to do the right amendments, make the right improvements, and therefore the whole thing sort of starts to crumble and fall down. Do keep your eyes peeled for my book, Slipology, which is going through its final edits as we speak and will be out later this year. And that's going to run through this whole model um, from bottom to top. So here are some key principles we need to think about, and these 6 things run throughout slipology. So in every single stage of that slipology pyramid, we need to be thinking about these 6 areas, which are called chimes. So these are the 6 reasons why people slip, and I would say tune your chimes to stop slips. Let's run through chimes and understand a bit more about what it means. So C is for contamination. If we have a floor that is perfectly clean and perfectly dry, then it's not going to be slippery. Simple as that. But if we introduce any kind of contamination which sits between the foot and the floor, that is going to change the risk of a slip occurring, whether that be water, grease, dust, semi-solids like grapes, anything that can produce a barrier between the foot and the floor is contamination. So we need to understand how much contamination we have, what the contamination is, where it's coming from, how frequently it's building up, how much of it can we withstand, etc., etc., etc. Next is H, heel. This is about the foot, unsurprisingly. Now, one of the big challenges here is safety footwear, and that's an all-encompassing term. The problem is that not all safety footwear is slip resistant. So you could have a piece of footwear that looks like it should be slip resistant, but actually doesn't perform as a slip resistant shoe. So that's one challenge. What are we actually using in terms of footwear for staff? But also, obviously, for members of the public, we can't be controlling what they're wearing on their feet. And in those cases, one of the things we fairly often see is a lot of blame going on. So, of course, she slipped over. Did you see those high heels she was wearing? Well, hold on a sec. Is it realistic? Is it foreseeable? Is it acceptable that this lady who sadly slipped over should have been wearing high heels in a train station or a restaurant or a pub or whatever? Well, yeah, of course it is. So we need to deal with the risks of heel on the basis of what is expected and reasonable in the areas that we're looking after the safety of. That was really bad English. I is for individual. This is the human factors. So gender and age play a role here. So statistically, you're more likely to slip and fall if you're an 80-year-old woman than a 20-year-old man. But also, obviously, the older you are, the more likely you are for that slip and fall to lead to a more severe injury. But what we're really looking at here, over and above just pure demographics, is activities. So if you think about it, walking normally at a standard speed in a straight line is one thing. But anything that we're doing that's introducing slightly kind of non-standard activity is going to increase the risk of someone slipping. So, for example, if we are pushing, pulling, twisting, turning, if we're carrying something, if we're distracted, if we're rushing, and you'll notice that all of those activities are going to be happening in stations. We're rushing for the train and we're pulling a suitcase and we're looking at our phone to check the platform. So we need to think about what we can do to mitigate the risks of those types of activities and to minimize them. Also under individual comes things like awareness, training, and signage. And I'm going to be speaking about signage a bit later. Next, we've got M, maintenance. This splits broadly into 3. Wear and tear, so floors will change over time. Change of use, so if we reposition a cafe, let's say, or a water fountain from one part of the building to another, we need to bear that in mind. and then cleaning. And we're going to be speaking about cleaning in a bit more detail later on as well. E is environment. So this covers obviously the weather, but also the built environment. So entrance matting, we're going to cover later. Steps and stairs, we're going to cover later. Ramps and slopes, lighting, noise, entrance systems. What type of doors have you got? All of these things are aspects of the built environment that could make it more likely for someone to slip. And then finally, S is the surface, which is the slip resistance of the floor, the grip of the floor in simple terms. And some floors are more slippery than others. If you think about walking down the high street in a big city, you're likely to be walking on some paving slabs or something similar to that. It can be hammering it down with rain, and those types of floors, as long as they're not overly contaminated and they've been maintained well, can still provide good slip resistance. But if you step through the door of a five-star hotel, let's say, you're often going to be finding a polished stone floor, and in wet conditions, that type of floor is just much more slippery. So that's a run through of chimes. Those are the 6 key factors that we need to consider throughout this whole journey of trying to deal with slips. And the way that we look at this is we need to understand how we're doing in each of the 6 areas. And then we need to think about which are controllable and under what circumstances are they controllable or not. We should be aiming for consistently high performance across all 6. But if there are any that are less controllable or perhaps even uncontrollable for us for whatever reason, then we should put more emphasis on the others. So it might be that, if we're aiming for a maximum score of 10 in all areas, we're aiming to achieve an 8 across all 6. But actually, if there are 1 or 2 we can't control, we should aim for a 10 or a 9 in the 5 or the 4 to 5 that we can. Hopefully that makes good sense. So having heard that, let me know in the chat, which of the chimes do you feel that you in your building or buildings are strongest at, and why? So give us a bit of flavour. We're good at surface because we've got excellent floors and we just relaid the floor, and we know it's anti-slip. Or we're good at individual because we focus in on safety culture and we do a lot of work on human factors, whatever it might be. But just share some of your insights and thoughts and experiences of chimes now that you've kind of been exposed to that methodology. Now, we have worked with over 1,000 sites now, and we've got them to a point where they've been able to score their performance on chimes. And this is the average score. So across all sectors, in different industries, and even in different countries, this is the average. So the average building is doing quite well at managing heel. It's doing quite well at managing its maintenance and its environment. A little bit worse at managing contamination, but still pretty good. But where the average building needs to improve is on individual and on surface. I'll explain to you how we know these numbers in a minute. So if you said to me, Christian, I've enjoyed this webinar. I'd love for you to help me do a bit of a deep dive on some of the ideas and the key thoughts you've expressed in the webinar, and see what we can do to reduce our slip risk in our stations or our business or whatever it is. One of the first things we try to do is get a benchmark for where you are now. And if you presented to me with this profile, the first thing I would say is, right, we need to get up the scores for individual and surface and try and get to some kind of equilibrium. And then after that, we then move on and try and continually improve the other areas. So how do we know what the average building scores on chimes? It's because we've developed a free self-assessment tool called the Slip Prevention Scorecard. It's basically like a mini quiz. You log on and it takes about 3 minutes to answer a series of questions about your building. And then as a result of the answers you give, you get scores for each area of chimes plus an overall score. So this is a great way, now that you've seen this chimes framework, to get a very quick snapshot of how you're doing on those 6 areas. So what I'd love to do is for everyone to give this a go. So there's 2 ways to access it. You can use the QR code on the screen, or you can go to scorecard.slipsafety.co.uk. You can log on and just whiz through and answer the questions. And as I say, it takes about 3.5 minutes on average to do that. Whilst you're giving that a go, I will talk you through a customer that we've worked with that started their journey off with the scorecard, excuse me, and made some really good and interesting progress and outcomes off the back of it. So click on the QR code or head over to scorecard.slipsafety.co.uk, start answering the questions. And this next bit, you can be multitasking. I would normally not ask people to multitask when they're joining me on a webinar, but I think for this, it's a really valuable exercise to do. So you can multitask on this. I'm just going to talk through the journey of how the scorecard worked with this particular customer. So this was a manufacturing facility, and they came on to a similar webinar to this, and they learned about the scorecard, and they thought, right, we're going to give this scorecard thing a go. So this is the kind of output you get, where you see here a little screenshot where you can see a score for contamination, heal, individual, maintenance, environment, and surface. So you can see here that this particular business actually scored 100% for environment, and they scored pretty well for heal, in the sort of amber zone for maintenance, but they had room to improve on contamination, individual, and surface. Now, if you do the scorecard, the main things you get are you get a report with all of your scores and some thoughts on what you can do, but you also get the invitation to come and have a Zoom session with me personally. I still manage somehow to do these myself, where we can review the scores you've got, and I can just give you some insights and experiences from similar clients to you, or from other sectors where maybe the scores and the profiling were similar to yours. So we did that with this client, and then we recommended that we did a on-site visit where we did a full review of chimes in depth. We did some slip testing, which I'm going to speak to you about in a minute. We did lots of other measurements around all of the other areas of chimes, and then we put together a report and some recommendations. So that on-site visit, we were able to cross-check with the findings they had from the scorecard, verify what the findings of those things were, and then start to look at some of the solutions. What did this business do as a result of that? They did a few things that had a big impact. So they improved their cleaning regime because they started to understand what contamination they had and how to manage it better. They introduced some areas of matting and some other methods to control contamination to prevent that contamination from building up. They improved their training. They changed some of the staff activities. So they re-engineered some of their ways of working to avoid things like carrying and pushing items around corners where possible. We helped them with some anti-slip treatments of some foreseeably wet areas, and then they put in place a much better and more robust specification for floors. So as they start replacing floors or introducing new areas and growing the business, they've now got a more robust specification. So it started off with a very quick quiz that took 3.5 minutes, and it ended up with a number of very robust, very measurable, very actionable outcomes that they've put in place and managed to mitigate their risk pretty well. So I've spoken about the science of slip prevention. One of the key things we have to do if we're talking about science is we have to measure. And slip testing is a really key aspect of this. Slip testing enables us to measure 3 of the 6 chimes. So of course, we're measuring the floor, but we're also getting an informed view on the maintenance and on contamination control through slip testing. Now, if you've not heard of slip testing, I'm going to show you a video of how it works. But Network Rail has a standard that they have written. It's called BLDG-SP80-001, Guidance on the Planning and Management of Station Flooring to Public Areas. And what that document says is that all floor surface materials should achieve or must achieve a minimum target rating of 40 SRV slash PTV. I'll explain what that means in a minute, when the material is both wet and dry. So Network Rail is saying that they would expect that passenger floor areas in their stations should achieve that standard. And it goes on to say, where minimum standards for slip resistance are not met, interventions are to be put into place to improve the floor's performance. So that's what Network Rail is saying. So how do we get that number? How do we understand what number our floors are compared to that standard, as well as the HSE standards? So what you need to use is something called a pendulum test. Let me know in the comments if you've ever come across a pendulum test before or not. I'm going to show you a video of it in a moment. It's called a pendulum because it swings. It's used by the HSE. It's used in courts here in the UK. It's designed to mimic what happens when someone walks along and their heel strikes the floor. And the output of the test is a pendulum test value, a PTV. So previously I mentioned the Network Rail standard talking about SRV or PTV. It's the same thing. And with this test, you can test any floor in situ. Andrew says we use STV rather than PTV. What's STV, Andrew? Is it basically the same thing, or is it referring to something else? I'd be interested to know. Let me know in the chat. So here's a video of the pendulum test being used. What you're going to see is this chap is going to spray the floor with water. He's then going to release the foot of the pendulum. And as I said, it's called a pendulum because it swings. The foot is going to swing down and strike the floor. And as it strikes the floor, watch carefully how that happens. And what you'll see is that it mimics how your heel strikes the floor when you walk along. The foot then swings through to the left. And as it swings through, it pushes a pointer onto a gauge on the left-hand side of the machine. And the number on that gauge is the pendulum test value. So let's watch this video. So spray the floor, release the foot, swing, and then we get the number. Show it to you again. So hopefully you can see from that how that is mimicking how you walk, basically, how a person walks along. So let me know in the chat, have you ever heard of this? Or is this a brand new concept to you? Have you ever done a slip test of your buildings? Do you know whether your platforms and your concourses or your office washrooms and entrances and your restaurant areas achieve certain slip resistance values, or is this something that is kind of new information to you? And if you'd be interested to learn a bit more about a slip test, then just type slip test into the chat wherever you're watching this, and we can send you some more information. So I said the output of the test is a number, and that's the pendulum test value. So why would you slip test your floors? The first reason is to reduce risk. So you can see here on the screen, if you score 36, then you have a 1 in a million accident risk exposure, and that would be a low slip potential according to the UK Slip Resistance Group and the HSE. If you scored a PTV of 29, if we just work down on the bottom of this screen here, you'd have a moderate slip potential and an accident risk exposure of 1 in 10,000. Whereas if you had a PTV score of 24, you'd have a high slip potential and an accident risk exposure of 1 in 20. So it's only 12 points difference on the PTV score between 24 and 36, but it's the difference between 5% of people being exposed to the risk of a slip versus 1 in a million. Now, if you don't know where you are on this gauge, on this chart here, then you're just going to be guessing or assuming. And there's a saying about assumption, but it involves a swear word, so I can't say that. But let's not assume. Let's measure. Let's quantify. Let's deal with the science and deal with the data, because what we measure, we can manage. So the first benefit of the testing is that it allows you to plot yourself on this chart and figure out where your current risk exposure is, and then obviously you can see what you can do to reduce that risk. The second benefit of the testing is that it helps you to defend claims. So David Scott here is a lawyer. He works for Keogh's, and he oversees leisure and hospitality claims for clients like Bourne Leisure and Virgin Active. And I interviewed him on my health and safety podcast, and we were talking about somebody slipping around a swimming pool and feeling as if they'd be entitled to make an insurance claim. And David said no, because if you're the operator of that swimming pool and you can prove that you've taken reasonable steps to reduce risk, and in his words, if you've got the compliant slip test data, you should expect to defend that claim. Remember, your obligation is not to prevent all accidents, it's to take reasonably practicable steps. And when it comes to this area, the Network Rail guidance is pretty much spot on. If you have got a PTV score of 36 or above when the floor is wet, you're in a very, very strong position, in my experience and in David's experience, the insurance companies we work with, etc., to defend claims, because you can prove scientifically that you've achieved the HSE standard. I'm going to give you a few thoughts around how to go about approaching slip prevention. And hopefully this will just get your mind whizzing and whirring, and you can go away and think about implementing some of these ideas. The first thing is to treat floors zonally. So we work with lots of big clients, and I remember once meeting with a supermarket chain with thousands and thousands of sites, and I asked to see their slip risk assessment. Firstly, they didn't have a slip risk assessment. They had a slips and trips risk assessment. And secondly, in spite of having lots of sites, all of which were different, lots of different types of sites, including offices and distribution centres and petrol stations, as well as high street and sort of retail park, larger format superstores. This was a very, very brief document and a very, very generic document. If we looked at a map of where slips happened for that business, or indeed for your business in your building, what you're going to find is, over time, that the Pareto principle applies, the 80-20 rule, but it's actually even stronger than that. In my experience, it's only about 5% of your floors where you have the strongest risk. So 5% of floors, but that would be the areas like your entrances, your washrooms, anything external, kitchens, bathrooms, showers, swimming pools, loading bays. But these are relatively small areas. But these are the areas that are going to get wet or contaminated without question. The rest of your areas, the 95%, are not going to get wet or contaminated foreseeably or regularly or frequently. So what we should be doing is focusing in on the 5% and making sure that those areas are safe when wet, per the slip testing. And then in the 95%, we just need to focus in on keeping them clean and dry as regularly as we can and dealing with spillages. So what you don't need to do is carte blanche everywhere. Nobody would expect you to have anti-slip floors everywhere because that's not reasonable or practicable. The way that we approach this is shown here on the screen. So what we're looking at are two things. We're looking at the slip risk per the pendulum score, and then we're looking at the foreseeability or the level of likelihood that a floor is going to get wet or contaminated. So if you've got a floor that achieves a low slip potential, a PTV of 36 plus when it's wet, then that's all good. Monitor it. Whereas if you've got a floor that fails to meet 36 plus PTV, but it is getting wet or contaminated constantly, then that is a problem. And therefore you should try to address that. So this is kind of that zonal approach. So if we looked at somewhere like Victoria Station, I just got this map off the internet. And if Victoria Station said to us, well, we want to address our slip risks, how would you advise we do it? We would advise doing it on a zonal basis. So you would look at the toilets, you would look at the entrances, and then any other areas that are most likely to get wet. So you'd be doing that kind of 1, 2, 3, 4, 5, 6, 7, 8 zones in the station is where the highest foreseeable risk of slips are. You wouldn't worry about everywhere else. You'd focus in on the areas where you're going to make an impact. Matting. We don't need a safe floor. We don't need to worry if our floor is slippery or not because we've got entrance matting. That's a commonly held feeling. This photograph is from a train station, and it shows that they have a decent amount of matting, maybe 3 meters of matting. But on a wet day, as evidenced by this photograph, the floor beyond the matting is getting wet. Matting is designed to dry your feet, and therefore, by the time you walk on the floor shouldn't be wet and your foot shouldn't be wet, and therefore you can't slip. The biggest problems with matting are, well, the biggest problem is that there's never enough of it. So on the screen here, you can see some data from the HSE and the Entrance Flooring Association, and the guidance is if you've got a high level of footfall, a high level of usage, which they define as 800 people per hour at peak using that entrance, you should have 8 to 10 meters of built-in matting. Now, the majority of buildings that I see have perhaps 1 meter, maybe 2 meters, sometimes a little bit more here. So if you don't have enough matting, it's not going to work. It's not going to keep the floor beyond the matting dry. The second thing is the maintenance. So matting is often not cleaned and maintained as well as it could be, and therefore it loses its efficacy over time. What you need to do is wait for it to rain. And bearing in mind we're in late June and it's heat wave time in the UK. It might not rain for a while, but the next time it rains, just stand inside and see if the floor beyond the matting is getting wet. If it is, then the matting isn't doing its job. Cleaning. Is this floor clean? This is in a shopping centre in Manchester. I suspect if you did a poll and you asked people to look at that floor and say, is it clean? They would say yes. It's not until you clean a patch that you realise that it's not clean. So looks can be deceiving on cleanliness. A floor that's consistently dirty can look clean. You need to verify if it's actually clean or not. You can use a slip test to do that because you can slip test a floor and then clean it and slip test it afterwards. You can use a hygiene safety test like ATP or something like that. Or, feel free to invite us in and we can come and have a look for you and do a little patch like that and show you visually whether it's clean or not. But we can't assume that a floor is clean just because we are cleaning it. All of you are cleaning your floors to varying degrees, but just because you are cleaning doesn't mean that it is clean. And therefore it doesn't mean it's safe. Signage. I'm just going to give you a second to read what it says on the screen. There's a picture of a CCTV footage from a supermarket. What would you say if I told you the pair of feet at the top of the screen belonged to a man who's about to die? And sadly, that is what's happened here. The man was called Stanley May. This was his local co-op store in Truro. He was walking through the store, and as you can see, there's a big spillage on the floor and a yellow sign. Put the sign out, we're covered. As long as the sign's there, we're okay. The sign will stop a slip from happening and it'll protect us even if someone does slip. That's what most people think about signs. In this case, not only did Mr. May's family make a successful civil claim against the co-op, there was also a criminal fine by Cornwall Council. And summing up after the case, it was a £400,000 fine. They said this: signage alone is not an adequate control. Proactive measures must be taken to either prevent floors becoming slippery or precluding public access. So there's only 2 times that you should ever use a wet floor sign. So when you go back to your stations, your buildings, whatever it is, have a look out for wet floor signs. Are they being used over and above these 2 times? And if they are, you've got a problem. The sign is a symptom of a problem. The first time is when you are proactively cleaning the floor. So absolutely, when you are deliberately making a floor wet by cleaning it, you should put a sign out to warn about that temporary hazard. And the other time is when you're dealing immediately and quickly with a spillage. You absolutely should put a sign out when you identify spillage. You should then clean the spillage up, dry the floor, and then remove the sign. Where do we see signs, though? We see signs plonked in front of the entrance and left there on a wet day. All that is saying is, we know we've got a wet floor. We know that it's slippery. Please don't sue us. But we know that we're not actually dealing with this problem properly. It's a symptom of the problem. Looks can be deceiving. Here's an example of a floor, checker plate floor, which was chosen because it looked like it should be anti-slip, but when it was slip tested, it wasn't. This is actually quite a new floor, even though it looks a bit grubby. But it was very slippery when wet. And it's in a hospital on a ramp where people are pushing and pulling trolleys up and down. You don't want a slippery floor in that setting. Here's an example of a floor that looks anti-slip if you look at it, but it's worn away. I've got another one of those in a second. So in the middle of this floor, it looks like it should be anti-slip because it looks textured, but it's very, very smooth and slippery. Under the shelving on the left-hand side, it's still very textured because it hasn't been worn away, and it is performing as anti-slip. And here's an example of a floor that looks anti-slip, but it's too contaminated. This is in a changing room of a leisure centre. So their belief was, we're okay, we've got a safe floor. When the floor was slip tested, it was very, very slippery. Once it was cleaned properly and effectively, they were right, they did have a safe floor, but a safe floor is only as good as the way that it's looked after. Here's some examples to illustrate this point from the rail industry. So on the left-hand side, can you see here that the floor has worn away? So this is the highest traffic point, and that floor has worn away. So they've installed the right kind of floor, but it's worn away through use, and therefore it needs some attention to restore the slip resistance. And then on the left-hand side here, we've got this is the same train operating company, but 2 different stations. And you see the yellow line on the left. That is very, very, very smooth and slippery. So the tile coping stone underneath has good slip resistance, but the paint has actually filled in the grooves of the floor underneath and left a smooth and slippery surface on top. Whereas on the left, you've got an example of where a proper slip resistant surface has been used that is effective. So if you've got a floor like that coping stone there, or a paving slab or whatever it might be that you feel is anti-slip, if you start painting stuff on top of it, you need to be wary because you might just be smoothing out the roughness of that floor and making it slippery. Let's just touch on stairs quickly because this is a key area. So when it comes to stairs, the consistency of dimensions is really, really key. And I'm going to give you a little tip that you can go away and do to look at this. So what you want to see is consistent going, which is the flat section, and rise, which is the vertical. Because when you walk downstairs, you put your foot on the first step, you step onto the second step, and then you switch your brain off, not deliberately, but subconsciously, you switch your brain off, and then you just put your feet in exactly the same place on every step as you walk down. So what happens in the majority of falls on stairs is that there's an inconsistency of dimension. So if you look here, this red step is inconsistent with the rest. That this person's going to put their foot down, make that first step, and then their mind will assume that the next step is exactly the same, and then they end up overstepping, and that's when they can fall. And this can also be exhibited in people tripping upstairs, because if you think of this in reverse, you're lifting your foot and moving it forward a particular height, and then your assumption in your brain subconsciously is every step is the same. So if you have then one step that is slightly higher, that's when you can trip. So what you can use here, just to go away and look at this very quickly, is what's called the crouch and sight test. So stand at the top of the flight of stairs and just crouch down and look. And what you should see is all of the nosings of the stairs blending into one continuous, sinuous line. And if it doesn't, then that's going to show you that you've got an inconsistency. And then you can see about trying to deal with that. Quick word on nosings. Nosings should be visible and consistent. So like on the left and the right and the middle here, we've got an inconsistency. And think also about nosings from a trip perspective. So on the right, this is from a cruise ship, but you've actually got a nosing, which is a raised area, and that's introducing a trip hazard. Here's an example from a station where we've got inconsistency of nosings coupled with some inconsistency of dimensions as well. And that's the sort of thing we should be looking out for and trying to fix. Sticking that tape there is not really solving the problem. So coming towards the end now, and I'm conscious of time as well. Get your questions ready and fire them into the chat if you've got any. Excuse me. So hopefully what you've got from today is that there's a difference between slips, trips, and falls. Slips is a much bigger problem, and slips are serious. They're scientific, but they absolutely are stoppable. I mentioned Euston. This was the data. This was published in the RSSB Right Track magazine. We did some work in 2011 over a few months, looking at what could be done to mitigate slip risks in Euston Station, and this was the result, a 60% reduction. So it is absolutely possible, even in these busy stations with massive footfall, to have a big impact. I'm not going to sit here and tell you that you can eradicate slips, trips, and falls, because that's not realistic. But you can have a big impact on them. Absolutely true and proven in Euston Station. And as I said earlier, there's several other examples, so you can stop these incidents from happening. So what's in it for you? Why should you care about this? Well, look, straight away, if you take this scientific approach to slips, like I've spoken about, you can have that certainty and measurable impact immediately to know that you're reducing risk. So this isn't safety culture where it's a bit fluffy, and I'm not saying that's not important, but this is something that you can do measurably, scientifically, have an immediate impact, and have that certainty that that's being done. And in the long run, what are you going to see? Well, less harm, more time, because you're going to be dealing with fewer of these incidents, and of course, lower costs. Here's what I'd love you to do next. Go and do, if you haven't already, the slip prevention scorecard, and then we can have a Zoom and have a one-to-one chat. Or if you're interested in getting a slip test and starting this scientific process off in one of your sites, just type slip test into the chat, and one of the team will get in touch with you. So, whizzed through a lot there, covered a lot of ground. Hopefully, you found it useful. Um, Summing up then, if you thought this was about slip testing and binning yellow signs, you've missed the point. We absolutely should be um, careful about yellow signs, and we absolutely should be doing some more slip testing. But it's not about that. What I'm known for is trying to bring this age-old problem back to the forefront of people's minds through a fresh and a scientific approach. And hopefully, what you've got from today is a feeling that it is possible to do something about this. You can have some confidence about it, and it is possible to control this risk. So, thank you for that. I'm now happy to take any questions. I can see a couple of things in the comment. Andrew, you mentioned STV, and you're using a slip alert, and you say it's HSE approved. I think if you look into it, you'll find that it isn't HSE approved. HSE says that testing can be a useful barometer, but the reality is, if you were in court in a civil claim prosecution against a claimant with a pendulum test that showed a fail and a slip alert that showed a pass, you would lose that situation. And the same in a criminal investigation. The HSE wouldn't come in and use a slip alert; they'd come in and use a pendulum. And if you had a pendulum test conducted by the HSE which showed that the floor was unsafe, and you were saying we've got a slip alert and it says it's safe, then you're not going to win that argument, I'm afraid. I'm not anti the slip alert because we recommend it for people to use. It's a very useful tool to use to monitor changes over time, but you shouldn't use it instead of a PTV. You need to use it to supplement the pendulum testing. Hopefully that's been helpful. Darren says he's used a pendulum testing for a number of businesses. Very good. Andrew, happy to have a call with you on that if you like. And someone asked about the data being normalized for weather. I don't know is the honest answer, but it was monitored over several months, and compared 2010 with 2011 over a period of months, and saw a consistent improvement month after month. So I don't know whether, I suspect they didn't do that. It wasn't my data. I was helping to do the improvements, but I wasn't collecting the data, so I didn't have anything to do with the data on that point. But I suspect it wasn't normalised for weather, but because it was over a few months, then I think it's probably pretty statistically relevant. Okay, guys, I think that's all the questions. So thank you very much for joining. Hope you've got value from that. Do go away and take the scorecard if you haven't, or if you're interested in a slip test, let me know. And thank you for being a part of Rail Safety Week. It's a really important initiative that happens every year, and we've all got our part to play in keeping our railways safe, but also, everywhere else safe as well. So thanks very much today, and I look forward to catching up with you sometime soon.